Okay, we're going to be looking at this third notes page here, still discussing different logarithm properties, although today we're going to be taking a look at solving, instead of logarithmic equations, we're going to be looking at solving logarithmic inequalities. So we're going to start seeing like less than, greater than symbols. But I'm actually going to start on this notes page at the back, because the back of the notes page is actually still discussing equations, which is what we have been talking about here so far. So we're going to use this as a little bit of a review and then a segue into solving logarithmic inequalities. I'll just draw your attention to the fact that it is reminding you here that you do, on the equations, you do have to check your answers for those domain restrictions. We don't want our arguments to be 0 or negative. All right, so a couple of these I have filled in for you. We're going to go ahead and do the few that are not filled in. Let's look at example 5. Okay, we can see that the property that we're always wanting to use when these are equations is the one-to-one property. So we want to make sure we've got one log on each side, that they have the same base, and that they have a 1 in front of them. We can see that that is the circumstance that is happening in number 5. So I'm going to go ahead and cross off the log and the base 10. Okay, and that leaves me with the argument on the left equaling the argument that is on the right. Okay, now some of these equations have been quadratics, meaning it has an x squared. We move everything to one side, we run the quad program. Other equations, such as this one, are not quadratics, so then we are just using our basic algebra skills here to move the x's to one side, all the other numbers to the other side, and we divide both sides, in this case, by 3. Okay, now remember, before we circle our answer, we're always wanting to check our answers for domain restrictions. The reason we throw a number out is not because that number itself is negative. It's because if we were to plug it back in for the x's, it would cause one of the two arguments to be negative. And I can see in plugging -1 just over here on this side, it would make that logarithm's argument a -2. And so that would be a cause that I should cross off that answer, throw it out. And if there is no other answer for me to go with here, then I'm going to just write down that my answer to this is going to be no solution. Okay, so that's what we're going to write down here, no solution. Okay, let's do one more review of an equation before we take a peek at inequalities here. Okay, we can see in this example, we have 2 logarithms on the left, no logarithm on the right. Of the 2 logarithms that we have on the left, I'm noting that we are asked to add them together, which means we should be multiplying their arguments. Now, the argument is 3x plus 1. We're going to want to multiply that by the other argument, x minus 1. So essentially what's going to be happening here is we're going to end up foiling together these 2 binomials. It's going to give us 3x squared minus 3x plus x minus 1. Okay, over here on the right side, we're going to need to turn that number 2 into a logarithm. Remember, the number 2 ultimately is going to go up in the exponent. I'm going to want to choose a number for my base that will match the same base number we have over here. I must also put that same number there in 8, and then the 2 actually goes in the exponent there. Okay. All right, one-to-one property says I can cross off the log and the base. I'm going to go ahead and kind of clean this up a little bit. I got 3x squared minus 2x minus 1. That's going to be equal to 64. Now, this one is a quadratic equation, so I'm going to be moving this 64 over to the other side, and then I'm going to run the quad program here. A is 3, B is -2, C is -65. Now, when I run the quad program, or if I graph it and find the x-intercepts, these are my 2 x-intercepts. I need to do a check here. 5 plugged back in, that looks like that checks out okay. 5 plugged in here, that also looks like that checks out okay. However, -4.33, if I plug it in actually to either of these two, I think it's going to make those arguments negative. So I'm going to throw that one out. I'm only going to keep x equals 5 as my answer. Okay, let's go back to the front and take a look at how things change a little bit here if we're going to be solving logarithmic inequalities rather than logarithmic equations. One thing that is going to be the same is you're going to actually still treat this as if it is an equation in terms of still wanting to do the one-to-one property. Okay, so we still want to try to get one logarithm on each side of the inequality. You can see in these opening examples here, all three of these examples start out with one logarithm on the left. However, there is only exclusively a number on the right. And so what we would want to do is we would want to change that number that we're seeing on the right so that it looks like a logarithm. So I'm going to choose 3 here, and then I'm putting the number 4 in the exponent. Okay. All right, now if I do the one-to-one property, remember you're only crossing off the log and the base. That leaves x is greater than 3 to the 4th, which would be x is greater than 81. Okay. Now there is one change here with these problems. These particular problems, I guess what we need to make sure that we're thinking of is that our domain restriction, okay, our domain restriction, this is a little bit different than equations where we would take our answer and we would plug it back in, because the answer that you're getting is not just a single number. We're not saying x equals 81. In fact, 81 is not part of our answer. We're saying x can take on any value as long as it's greater than 81. So there's this infinite range of answers, any number bigger than 81. Well, we're not going to test all of those numbers in here for x, but if you look back at the original problem, you can see that in terms of the original argument here for this particular problem, the restriction is that that argument has to be a number that's bigger than 0. Okay? And that's actually the case in all three of these problems. The restriction is that x has to be greater than 0, because x is all the arguments are in all three of these. It's nothing more complex than that. So if that's my restriction, x has to be greater than 0, because x is what my argument is. I just need to look at my answer and make sure the answer that I'm getting is agreeing with my domain restriction. So in other words, are numbers that are greater than 81 also numbers that are greater than 0? And the answer would be yes. Okay, that's true. So I'm going to go ahead, circle, highlight that. That's going to be my answer. All right, let's go ahead and try this next one here. I already have one logarithm on the left. I'm going to turn the number 3 into a logarithm. That's going to cause that 3 to bump right up there. I'm going to do the one-to-one property here, crossing off the log and the base. That leaves me with x is greater than or equal to 4 cubed, which is the number 64. Okay, again, before I circle this or highlight this as my final answer, I need to look back at my domain restriction and say, okay, are all numbers that are greater than or equal to 64 already numbers that are greater than 0? The answer is yes. I'm going to keep that as my answer. All right, now let's look at this next one. It's going to be a little bit different here. I'm going to turn the number 4 into a logarithm. Okay, again, 4 is going up there. I'm going to do the one-to-one property. That leaves me with x now is less than 2 to the 4th, or in other words, x is less than 16. Okay, so I want to say to myself, are numbers that are smaller than 16 also numbers that are always greater than 0? Well, some numbers that are smaller than 16 are greater than 0, but I'll give you an example. -5 is a number that's smaller than 16, but -5 is not a number that is greater than 0. And so what we're going to have to do is we need to make sure that we're not circling an answer that would indicate that there's a possibility that some of the answers could be in violation of our domain restriction. So we're okay with our answers being smaller than 16 as long as they don't dip below 0. Okay? So what you're going to do is you're going to attach to your answer this symbol. I know it looks like we're saying that this is a less than symbol, but the way that you read this is you're saying x can take on any number smaller than 16 as long as, see how the bigger opening's pointing towards the x? As long as x is also greater than 0. It's got to be smaller than 16, but bigger than 0. Okay, so we have to attach that onto our answer. Okay, let's look at similar types of problems. And what you'll notice about these last three, though, is you'll notice that the arguments of these last three are not just x, okay? There's some extra numbers thrown in here. And so here's what you're going to want to do to start these problems. You're going to make a list off to the side here, and we're going to need to list what the domain restrictions are for each of the logarithms that we have in the initial problem. Okay, now remember, the restriction to a logarithm is that its argument has to be greater than 0. Okay, now if you look at this first logarithm on the left, its argument is x plus 3. Okay, so that's representing a number. We don't know what number it is because we don't know what x is, but we need x plus 3 to be representing a number that is definitely greater than 0. So I'm going to set that up. I'm also going to, I'll leave a little space here for us to solve that. I'm also going to write the argument of the other logarithm in this problem, 2x plus 1, and I'm going to say the same thing. That is representing a number. It has to be a number, though, that's definitely greater than 0. Okay, so what we're after is we want to solve both of these inequalities for x. Okay, so I'm going to bring the 3 over. I'm just going to put a little star next to that. Okay, and then over here, we're going to subtract 1, and then we will divide both sides by 2. Here's our other domain restriction. I'll put a little star by that. In fact, I'm going to go ahead and just circle those two domain restrictions here in green so they'll be easy for us to look at. When we get to the end of this problem, we're going to need to come back and glance at these domain restrictions so we make sure that our final answer would not ever violate either of these two domain restrictions. Now, the good news about these last three problems is if we're doing the one-to-one property, which is what we're doing for inequalities as well as equations, is these look like they're already set up nicely where there's already one logarithm on each side of the equation. So we're not having to combine logs together, we're not having to turn numbers into logarithms. We can simply cross off the logs from each side, provided they have the same base and that they both have coefficients of 1s. Okay, now that leaves us with this here. Now, there is one important thing that I haven't mentioned yet with inequalities, and that is when you're solving an inequality, if you ever run into a situation where you have to divide both sides of your inequality by a negative number, you have to flip the direction that the symbol is pointing. Okay, so I'm going to move this 2x over here. I'm going to move this 3 to the other side. Okay, now my symbol right now is a greater than symbol. That's going to give me negative x on the left, negative 2 on the right. Now look at what I'm doing here. I'm dividing both sides by a negative number. Okay, now that's when I would take my symbol, I would flip the symbol the other direction. And so initially I'm getting that x is less than 2. Okay, here's where we need to look at our domain restrictions. And here's what I think the easiest way to do this. I like to draw a number line, and I like to graph above the number line, and I'm just going to put 0 here. I'm going to mark off down to -3, and I'll mark up to +3. Okay, I'm going to go ahead and mark above the number line what I'm saying my answer potentially is, that x is less than 2. Okay, now it's not equal to 2. If it's less than 2, I'm going to put an open hole above 2. Less than means I'm going to the left. Okay, then I'm going to take my first domain restriction. I'm going to highlight that in blue. I'll go ahead and graph the first domain restriction also above the number line. It says x is greater than -3. So I'm going to put an open hole above -3, but because it's greater, I'm going to have that arrow going to the right. Okay, now I'm going to go ahead and highlight my other domain restriction here in purple. I'm going to graph that one also. X is greater than -1/2. So -1/2 maybe would be right about there. Greater, I'm going to the right. Okay, what you want to be looking at these three rays that I have sketched here is you want to be looking at them vertically and ask yourself, where do all three of these graphs agree with each other? Okay, so it feels like right here at, I think this is at -1/2, they feel like they start to agree. And then you can see how there's blue, purple, orange. They're agreeing all through here. As soon as we get to this value of 2, they stop agreeing with each other. Okay, so I'm going to highlight, feels like they are overlapping in this space right here between -1/2 and +2. So that I need to write that as what my answer is. Everything less than 2, which is what I have right here, but I'm not allowed to go any farther to the left of -1/2. So I need to cap off and put this symbol on the other end of my answer here. So I'm saying as long as x is less than 2, but still greater than -1/2, I will be okay with having solutions that will not violate either of my two domain restrictions. Okay, we're going to try a couple more, make sure we get the hang of this here. We'll pick up the speed with this here. Okay, where you're wanting to start is you want to look at each of your logarithms arguments. Off to the side, I do need to see these domain restrictions. Okay, so this is not optional that you're writing these down. I need to see the domain restrictions. Set each argument greater than 0, and then solve each inequality for x. Okay, so I'm going to go ahead, I'll highlight the first one in blue. We will solve the second one. I'll highlight that one here in purple, and then we will come back and we will revisit that when we get to the end. Okay, now we're going to come back to our equation. This is set up nicely for the one-to-one property. We'll cross those off. I just need to solve the remaining inequality here. I'm going to move the x to this side, move the 1 over to the right. Looks like my initial answer is that x is less than or equal to 3. So I'm going to make a number line. I like to look at what my numbers are. Here's 3, here's -4, here's -1/2. Gives you a sense of sort of what you need to be putting on your number line here. And I'll just mark that that's -1/2. I'll just put those numbers on. Okay, so in orange, I guess, I will go ahead and graph my initial answer. X is less than, this time it's less than or equal to 3. So if it's equal to, I'm going to put a closed in dot, going to the left. Okay, now I'm going to graph with a blue line this domain restriction. X is greater than -1/2. I'm going to go that direction. And then with a purple line, I'm going to graph this domain restriction. X is greater than -4. Okay, so I'm going to look back and say, where do all three of these lines look like they begin to overlap? Feels like they start to overlap right here at -1/2. Looks like they stop overlapping right there at 3. So they are overlapping every place in between -1/2 and 3. So I go back to my answer. I'm okay with saying anything less than 3, less than or equal to 3, but I need to put a barrier and say, but it has to be greater than the -1/2. I'm not going to go any farther to the left of -1/2, or I'm going to be violating one of my domain restrictions here. Okay, last one. Let's do our domain restrictions here. Okay, domain restrictions. We are going to take each of our logarithms arguments, force those to be greater than 0, solve for x. Okay, we'll highlight the first one in blue, second one in purple. Come over here and do the one-to-one property with the inequality. All right, we're going to solve this for x. Okay, initially, looks like we're getting x has to be greater than -3. If I look at my other numbers here, I got -5 and -4. So I want to make sure that I'm including those on my number line. Okay, in orange, I'm going to graph my initial answer here. X is greater than -3. In blue, I'm doing that domain restriction. X is greater than -4. And in purple, x is greater than -5. So again, we're going to look and say, well, where do these overlap? Well, it looks like they don't start overlapping until -3. But then once we hit -3, it looks like they just keep overlapping all the way to the right, to the right, to the right, to the right forever. So I'm not needing to put anything extra up here to cap this off. Once I hit -3, I'm good. They are all in agreement with each other. So I'm going to go ahead and just circle this as my answer. Okay. All right, I believe there are a few problems on this worksheet here that you can go ahead and try. Some of them are inequalities, where you'll have to do this domain restriction here at the beginning. If they are equations, these are the ones when you get to the end, you are plugging them back into the arguments to check to see whether you need to